And well, let us start with the way we have this free textbook found. I know some people just added the class, so we can again double check how the textbook is found in the Google search by just typing the 10th edition of Intermediate Algebra by Gustafson and PDF at the end. So remember, that's the most important part, to put PDF. So then I can select the first choice and get it for free. You can see the other choices down below. They, of course, trying to charge people for this textbook, but I think the free textbook is pretty good deal, right? So we'll just use the one here, and looks like it takes a little time. So I'm going to put this link to the textbook in the chat. So if you already have the textbook, make sure that you download it, right? So I can put this in a share of a link with everyone. I guess first few class meetings I'll keep doing it, so make sure that everyone has the textbook. So last time we kept working on chapter 1, so we went to the equations part of chapter 1. So I want to take a look at some of these solutions. So I need to go to page number 48. So to get there, I put 58, right? So I need to add 10 or so to the page to get there faster. So it looks like we get to, actually, I should have probably added more than 10. I probably should have added like 20. Well, anyways, so section 1.5 that refreshes on how we solved those equations. And the way we always solve equations is same. We need to find unknown letter x. So to find x, or to isolate that letter x, I need to do the same exact operations on both sides of my equation. So let me try the problem number 67. And of course, I'm looking forward to hear if you have any questions that I should help you with. Just tell me the problem number so I can work it out for you. So equation says 5, subtract a fraction with x plus 2 over number 3, and this is equal to 16, oh, actually 7 minus x. So once I wrote down this equation, one can say, Alex, I can see the answer. X is equal to 4. Yes, that's correct. There is an answer to this exercise, but you definitely want to put some work in order to solve it. And the key part is to make sure that our denominator, the only denominator I see here, number 3, will be cleared. So we want to make that 3 to go away by multiplying both sides of my equation by that denominator of 3. So you have to times by 3 on the left side and the right side of this equation, so that 3 will simply cancel, and that will make me feel much better because I don't want to see any denominators in this exercise. So I just copy everything that's left, but I have to put parentheses around my numerator. The reason I must do this is because that x plus 2, that numerator needs to be subtracted. So then I just continue copying everything else. I multiply by 3 my left side and the right side of this equation, so that denominator was canceled. And now we can proceed with solving this for unknown letter x. So our goal is already here. We know that the answer should be 4, but it's definitely not that simple to see that our answer is 4 at this stage. I need to little by little bring the x terms on one side of the equation. So I change sign with minus 3x, and then all of the numbers I can bring over to the right side. So positive 15 becomes minus 15, and then minus 2 becomes plus 2. Of course, you can solve this equation any way you prefer. I'm not going to tell you that my approach is better, but I guess you get the answer, which is the same for all of these solutions. So right now, I found that 2x was equal to number 8. And then to get x out, I need to divide both sides of this equation by 2. And we see that indeed the value of x is 4. So solving this exercise definitely takes a little bit of work. And the point of this process is to make sure that you actually do those little steps in order to find what this unknown x is equal to. So I want to tell that I put the grade for everyone on the blackboard. Even if you just join the class, I put perfect grades to start. So make sure that you feel comfortable with this class, and to actually show everyone that I really want you to succeed. So that's why I put A's to everyone. But if someone stops participating and taking quizzes for class, well, the grade might get a little bit lower. That's why I also mentioned that you can increase your grade by doing a few extra credit exercises. Of course, if you want to do this, because that's extra credit. So anyways, let me try to solve another equation here. Let's say, how about problem number 71, just to see how we clear those denominators, how we make those denominators to disappear. So whenever I see equation with denominators, the idea is to make sure that those denominators will cancel, will go away. So the left side is here, sum of two fractions, and on the right side is 2 over 15. So usually the largest denominator, which is 15 here, is going to be a common denominator. So I can multiply by number 15 every single term of my equation. So I have 2 pieces on the left side and 1 fraction on the right. So when I multiply by 15 my first fraction, then denominator disappears and we have 5. Please notice that when I multiply the fraction by that common denominator, I need to put parentheses, just like in the previous example. So once you have those parentheses, the 5 here and then 3 will be distributed over my numerators. That's the way to go. So you want to make sure that you multiply your entire fraction by that common denominator. So I distribute 5, and then over the second fraction, I distribute number 3. So my equation at this stage becomes much, much nicer, simply because we no longer have any denominators. So now I can put this so-called like terms together, such as terms with letter A, 5 and 3, and also when I subtract 3 from 5, here I get number 2. So little by little, our equation gets nicer, and then we can subtract number 2 on both sides of this equation and get 8a's is equal to 8 times a is equal to 0. So what is a? When you say, Alex, I just saw the answer, it is 0. Yes, we can definitely see that a is equal to number 0 when we divide on both sides of this equation by 8, right? So here's the result. So the point is, when you do some work in these sections, you want to make sure that you actually put all the steps on a piece of paper, because if you just put the answer, well, for problems like this, you definitely can't see that a is equal to 0 right away. So all this work should be provided. And remember, I asked you to do this so-called homework for every section that we done in this class. And then when we have a midterm exam in the middle of semester, it'd be, I believe, at the end of February, you should show me your homework. And well, I guess a few problems from each section would be good enough. So for example, if you can do problems that I just solved, 67 and 71, and produce the same exact answers, well, I think that'd be enough for homework, because the other exercises in this section are pretty much the same. It just keeps talking on solving more and more equations. So I'd like to skip the rest of this chapter 1, because the sections here just solving, well, basically more equations, and they also contain so-called word problem exercises that I let my students not to do if they don't want to. And last 2 sections of this so-called review chapter are all designed from those so-called word problems. So we can just skip those last 2 sections and move on to chapter 2. And we'll just continue with equations of lines, or graphing various linear equations, just like they have here on the figure 2.6. And turns out that our goal will be to see, when you are given the equation, that this is actually linear equation, or equation of the line. And the way I can see this is by noticing that both variables x and y are just multiplied by some numbers, and that's what producing so-called linear equation, or equation of the line. And turns out that in order to graph this equation, all I need is just a pair of points. So once you have first point here, let's say point pair 0 and 4. If you replaced x with a 0, then this fraction will disappear, and you just have y is equal to 4, and that's exactly the point on the y-axis. And if you get any other point calculated, let's say if you utilized, say, number 2 instead of x, and then see that y will be equal to number 3, that should be good enough to produce the graph by simply connecting those 2 points together. So if you want to calculate more and more and more points, you can definitely do this, but it's going to be like a waste of time for us, because if you already have 2 different points, it's just enough to get the picture of your line. So that's what they're practicing in the section 2.1. They try to put numbers in and plot those particular points. So, for example, if I try exercise like number 31 here, remember we care about practice, so we don't want to worry about vocabulary exercises, a review, or so-called warm-ups. So you can just start with making so-called point plot on the plane, exercises and guided practice group. The point C has its first coordinate or x coordinate equal to 3, and second coordinate or y coordinate equal to number -2. So in order to plot point C, you need to put number 3 here on the x-axis and -2 on the y-axis. And once you put those 2 numbers, the point C will appear when you imagine yourself so-called perpendiculars to the x and y axis that started those 2 points. So I hope that you're already familiar with making pictures or so-called point plot on the plane of coordinates. So I can try to plot another point. Again, its coordinates are x and y, and they're given to be 0 for x and 3 for number y. And that's why to get that point H, I will put number 3 on my y-axis. Since the x is equal to 0, I don't really need to move away from y-axis, because if you imagine yourself the x-coordinate of this point, if you draw perpendicular to x-axis, you will hit 0 right in the so-called origin point. So we just stay at the position where point H is here at point 3 on y-axis. So the message is, whenever one of your coordinates is equal to 0, then the point must be on my axis. So if in exercise 36 we have 0 instead of y, then point is on y-axis. Let me try one more here, like number 34 exercise that says plot where x is equal to -4 and y is equal to 0. So in order to picture that point on my x-axis, I need to put -4, right, which is going to be to the left from 0, and that's it. Since y coordinate of that point is 0, we're going to have point F right here on x-axis. So points with 0 coordinates are here. And basically, all they want you to do is get various points calculated and pictured on your number lines. So what should I do to make some graphs on the next page? Well, let me try to check how we can produce problem number 47, for example, how we can graph that little equation here. And notice they actually recommend to plot 3 points, right? You can see that they used 0, -1, and 3 instead of x. So turns out that it doesn't really matter what numbers you utilize instead of your variable x or instead of variable letter y for this equation, but I would always prefer to use number 0, because when I replace x with a 0, then my letter x simply disappears, and what I see here instead of y is what's left, and that's going to be number -3. So I can plot point with coordinates 0 and -3 someplace on y axis, and that'd be a good start. So then I can try any other number to calculate, and I would prefer to use number 1 instead of x, and using number 1 I think is a little bit simpler, because if you replaced your letter x with 1, what you produce is 2 minus 3, which is equal to -1, right? And this will give me the second point, the point with coordinates +1 and -1, and that's someplace down below in here. And once you have 2 points that you plot on the plane xy, it's just enough to produce the graph of your line. You just connect those 2 points with each other. So I'll utilize convenient values such as 0 and 1 instead of x. So you can use technically any numbers you like, and you can see that here in this particular exercise they used more than 2 points, and I would say that's kind of waste of time to use more than 2 points, because once you determined that you're graphing the line, then 2 points just enough. So let me try another problem here, like exercise number 57, that tells that x is equal to 3. So how come the line here is vertical, right? You can see the graph of that line, which is vertical, because one can say, Alex, if x is 3, then the point should be someplace here on the x-axis, right? How come the equation of x equal to 3 is actually a line? Well, the reason is that we have points as pairs of x and then y coordinates. Remember, the x equals to 3 means that we have the line because nobody told us that y here must be equal to 0. We just have only equation for x. So it turns out that this equation has lots of different possibilities for y, because nobody told us For example, 3 for y will give me another point on the same line, on the same vertical line, because when x is equal to 3, y could be any number. Like here we have x is equal to 3, y is also equal to 3. Or y could be, for example, -2, so we have pair 3 for x and -2 instead of y. So the idea is no matter what y is equal to, x is always going to be number 3. And that's why all points that we can possibly think of will have the same exact first coordinate, the same exact x coordinate, which is equal to number 3. That's interesting to realize. So whenever your value of x is equal to some particular number, like in the problem 57, then y could be just about anything. So I'm going to try to do problem 49 just to verify that the line they graphed here is exactly how it looks like. So they graphing 3x plus 4 times y is equal to number 12. And what I can do is place 0 instead of x and see what will come out instead of y if I substitute 0 here in my equation, right? So when x is equal to 0, then we have a 3 times 0, which is 0, plus 4 y's, which is 12. So I can see that 4 times 3 is 12, right? Y has to be equal to number 3. So then I can see that point 3 is someplace here on the y-axis, and that's exactly what the line is passing through. So this is so-called point of intersection of this line with my y-axis. Maybe it's a good idea that you try to calculate one value as a little quiz for today. So could you tell me if y is equal to 0 in the exercise number 49, what is x? Could you please do exact same calculation that I just done in problem number 49? So you use this equation, and now instead of not x, but instead of letter y, you should try to put in 0. So once you replaced letter y with 0 and found what x was, please put your answer here in the chat. So this way I can see that you are here with us. So that'd be a little quiz for today. But please make sure that you send this answer only to me. So you once use the Zoom chat, you can select my name, not send it to the whole class, but only to Alex, please. So once you're done with the quiz, you can log out from this and enjoy the rest of the day. So, but please don't hurry, because I give you plenty of time to actually work on that little quiz. So again, today's quiz is to replace letter y with a 0 and put in the Zoom chat the answer. Tell me what x is equal to. And once you're done with it, well, you can just enjoy the rest of the day. So I'll see you again on Wednesday, right? But please don't hurry. The question is right here. I just wrote it. It's exercise number 49. Use the equation 3x plus 4y is equal to 12 and replacing it y with a number 0. So tell me which value of x corresponds to y equal to 0. So that's a quiz for today.